Alright guys, welcome to 1.6. Today we're going to be talking about absolute value inequalities. So we've talked about absolute value equations and we've talked about inequalities on their own, and now we're going to be combining those two concepts. So, flashback to absolute value. What are the two bars around the number sign called? Absolute value bars, right? Nothing new. So fill that in. They make any value in between those two bars, what? Positive. Okay? How many different numbers can we put between the two bars to make the following mathematical sentence true? This is the same one that we already did, right? We said we could put -7 in there, and the absolute value of that would be 7. +7, obviously the absolute value of that would be 7. And then, of course, we could throw in some improper fractions if we wanted to, but we know those are just going to simplify to 7. Take the absolute value of that. It's obviously 7. So we'll keep going. How this is going to work. Okay, so again, we've solved the inequalities before, but this is just going to be adding in the absolute value thing. So if we remember back to what we know about absolute value equations, we remember we had to split it into two, right? We're still going to be doing that. But we've got to pay attention. We've got to pay attention to our signs of these inequalities, okay? And just a real quick flashback, if you need to write them over on the corner, we had our greater than sign, less than sign, greater than or equal to, less than or equal to. Those are those four symbols, okay? So those are still the same. We're still using those. And make sure we know the opposites. So these two are opposites, and these two are opposites. Okay, so how to solve these inequalities with absolute value bars. So our very first step is going to be just to isolate the absolute value. Okay, so just like when we solved the absolute value equations, okay, don't judge my handwriting. Second step, make a decision. So this is different than the equations. Make a decision if it's an and or an or. This isn't too hard to do, okay? So once it's isolated, all you got to do is look at the sign. If it's a greater than sign, so greater than or equal to, then it's going to be an or, okay? If it's a less than sign or a less than or equal to, then it's going to be an and. Think about the words greater and less than, okay? Sounds cheesy because it is, but that's going to help you to distinguish that and remember that. So if it's a greater than sign, it's going to be an or problem. If it's a less than sign, it's going to be an and. Okay, and we'll talk about what that means here when we do an example. The third step then, just like the equations, now we're ready to split it into two problems. Okay, the first split, just keep it all the same. So drop the bars, keep it the same. Don't change anything. Second split, okay, so same as the equal sign, you drop the bars and make the right side negative, so make other side negative. You also have to do one more thing though. You also have to flip the sign. And that's important, okay? So just on that second one, you're flipping the sign, making the other side negative. Fourth step is just to solve and graph, just like normal. And then we'll check for those extraneous solutions. We'll do a couple examples on that, but don't get too caught up in that step. Okay, so get this written down. Now we're going to move right along. So starting off with example 1, okay? First step, isolate the absolute value. All that means is just get the absolute value on one side, all alone, everything else on the other side. Is this one isolated? It is, okay? The whole absolute value, it doesn't have anything else with it. it's all on the left side. Everything else is on the right side. Okay, so first step's already done for me. Second step is to make a decision. Is this an and or an or problem? Remember, greater and less than. What sign is this? Is this greater or less than? It's a less than symbol. So I'm just going to write the word and over here. Okay? And that's going to tell me that my goal for this problem is I want it to look like a line segment, right? Anytime we have those and problems, we want them to look like a line segment. It's where the two different problems have in common. So we'll go ahead and we are going to split this into our two problems. Okay? First step, or first problem. Keep everything the same. Just get rid of those bars. X plus 3 is less than 9. Okay? Next step, drop the bars, flip the sign, and make the right side negative. Okay? Are we good so far? Hopefully you're with me. Now we're just going to solve these two problems. So the first one, just trying to get x by itself, so I'm going to subtract 3 on both sides. I end up with x is less than 9 minus 3, which is 6. Okay? Same thing on this right side problem, still subtracting 3. Since it's just subtracting, it's not multiplying or dividing by a negative, I don't flip the sign. Okay, I'm just subtracting 3 on both sides, keeping those signs the same. Negative 9 minus 3. Oops, there we go. Negative 9 minus 3 is negative 12. Okay? So now I've got my two answers. And now I'm ready to graph. So I just need to put these two numbers on my number line in order. So negative 12 is going to come first. What kind of dots are these going to have? Well, remember, if it's just a less than and just a greater than sign, then it's just going to be an open dot, okay? Because it's not equal to. So if x is less than 6, I know I'd be shading this direction. If x is greater than negative 12, I'm shading this direction. It's an and, so it's what they both have in common, and it looks like a line segment. Okay? So that tells me I did it correctly. Well, hopefully. Let me, real quick though, just check for those extraneous solutions. How this works, okay? So it's a little bit different than the previous way that we checked for extraneous solutions. So how we need to do this is we need to plug in a number in each different portion of this graph, each interval of this graph, okay? So we can see here that everything less than 12 is not shaded, or negative 12. Everything less than this is not shaded. We don't have anything defined on our graph for that point. Okay, so if I plug in a number that's less than negative 12, it doesn't matter what number it is, if I plug it into where I isolated from, okay, I should get an answer that doesn't make sense because there's no shading there, okay? So let's just pick a number less than negative 12, any number. I'm going to pick something easy. I'm just going to do negative 20, okay? So I'm going to plug in negative 20 over here. Negative 20 plus 3 is just negative 17. The absolute value of negative 17 is 17. Is 17 less than 9? No, absolutely not, okay? So it's good that I don't have shading there, okay? It means it's not a solution, which doesn't look like it is. So we're going to do that exact same thing, but now we're going to plug in a number that is in this interval, okay? So any number between negative 12 and 6. It should work for anything that's between those two numbers. So let's pick something easy. How about 0? That's pretty easy. Okay, so I'm going to go and plug in 0 to this problem. 0 plus 3 is 3. The absolute value of 3 is 3. Is 3 less than 9? Yes, it is. Okay, so it's good that I have that shading right here because it tells me that is defined. Okay? And then last part, something here on this right side interval. So again, I can pick anything that's bigger than 6. So whatever you want to do, I'm just going to use, we'll just do 7, okay? Plug in 7 to my problem. 7 plus 3, 10. Absolute value of 10 is 10. Is 10 less than 9? No. So it's good that I don't have shading there. Okay? Don't let that step trip you up too much. For the most part, you're not even going to really have to deal with extraneous solutions. Okay, but we do know that there were those 2 cases, the all real numbers and the no solution, where we did deal with that. Okay, and we will see that today. I'll talk about how to spot it early on, so that way we don't even have to get to this step. But I just want you to know that it is good to get in the habit of checking your extraneous solutions, but you're not always going to have them. Okay? Okay, we're going to be doing a little bit of skipping around on these just because I don't love the order that the problems are in. So go ahead and join me on example 4. That is going to be the next one that we do. Okay, so first off, we have to get this absolute value isolated. Okay, so the first step, need this to be on a side by itself. What's keeping me from having that on a side by itself? This plus 5 right here. So I got to get rid of that. Got to get that over to the right side. So to get rid of a plus 5, the opposite is to subtract 5. So I now have absolute value of 4x minus 5 is less than or equal to 3. Okay, I drew that kind of weird. There we go. Alright, am I isolated now? Yes, I am. So I'm ready to split. But first, let's look, is this a less than or a greater problem? We will see it is a less than sign, right? So I'm going to write the word and up here. Again, that's just to let me know. I know in the back of my mind what this should look like, okay? A line segment, right? So we'll aim for that. So first step is to divide this into 2. I'm going to come over here to this side just because I have a little bit more room. So first one is just to drop the bars, keep it all the same. Next problem, keep that left side the same, flip that sign, and make that 3 a negative 3. Okay? Now time to just solve these. So the first problem, first thing I would do is just add that 5 over, end up with 4x is less than or equal to 8. The x is still not alone. I've got to get rid of that 4, and I'm going to do so by dividing by 4. X is less than or equal to 8 divided by 4, which is 2. Okay. Next one, same thing. Add 5. 4x is going to be greater than or equal to negative 3 plus 5, which is going to be 2, right? And then divide by that positive 4. Don't have to worry about flipping it because it's a positive 4. 2 over 4 is just 1/2, right? You could write it as a fraction or a decimal, 0.5 if you prefer that way. I'm going to leave it as a fraction. Okay, coming on over. Put those 2 numbers on the number line. Which one is smaller? Definitely that 1/2, right? What kind of dots do I have on these? They are equal to, so they're going to be closed dots. X is less than or equal to 2, greater than or equal to 1/2, and that's a line segment, which is what I wanted. Okay, I'm pretty sure I did that one right. I'm not going to worry about checking extraneous solutions again. If this was a test, definitely check every single time, but I'm going to keep moving along on this one. So, okay, I told you we were flip-flopping around. Go ahead and go to example 6. That's going to be the next one that we do. Alright. First step, I got to get this absolute value alone. It's got a lot going on over here that we've got to get rid of. Okay? Again, if you have a hard time visualizing these problems, pretend that this was just a variable. Okay, so if I just had 2 plus 3x is greater than 8, how would I get that x alone? What would be the first step I would need to do? So hopefully you realize we've got to move the 2 first, okay? So same thing with the absolute value. We've got to subtract that 2 on both sides. Okay, we still have this 3 out front, right, which is annoying. We still got to get rid of that, but we can't move it yet. 8 minus 2 is 6. Okay, so again, pretend that this x minus 4 was just an x. If I had 3x is greater than 6, what would I do? Divide by 3, right? So same thing here. Going to just divide that 3 on both sides. It cancels out over here, and I'm left with absolute value of x minus 4 is greater than 6 divided by 3, 2. Okay, so now I've got a problem that is isolated, right? Let's look, what kind of symbol is this? A less than or a greater? It is a greater than sign. So I'm going to write the word or out there. Again, the or problems just mean what they don't have in common, okay? This or that. They're going to be two separated things, right? We're going to have that gap in between, and we're going to have lines going in opposite directions. So that's my goal there. If I know that it's an or, I know that I want it to have a gap on its number line, and I want lines going in opposite directions. If I get something else, I probably need to either go look at my work, maybe I did something wrong, or I need to check those extraneous solutions because maybe I have a special case of some sort. Okay, but we'll go ahead and try this one and see what happens. Ready to split it. The left side is going to stay the same. And the right equation, drop the bars, flip the sign, make it negative. So drop the bar, flip the sign, make it negative. Get in the habit of knowing that process. Okay, let's solve. I'm going to add 4. Add 4. Negative 2 plus 4. 2. Okay. Got my 2 answers. Now I can put these on a number line. Which one's coming first? 2, then 6. What kind of dots are these going to be? Open. Okay. If x is greater than 6, what direction am I shading? Greater means it's getting bigger, right? Less than 2. We're going this direction. Okay. This is what I wanted it to look like, right? It was an or problem. Okay. I'm going to leave it alone. I'm not going to worry about extraneous solutions on this one because it looks right to me. Okay, flip-flopping around still. Example 7 is going to be the next one that we do. Okay. This one is not isolated. We can see that the absolute value is not by itself. So I'm going to give you guys a little bit of time. I'm going to let the video play here for like 20 or 30 seconds. I want you to go ahead and isolate this one. So get this absolute value on its own. If you need a little hint, just pretend that it was this. How would you isolate that? Give you about 10 more seconds. Keep going. Okay, let's try it. So the first thing you should have done is just subtract that 5 over. So you'll end up with a negative 4. Absolute value of y minus 5 is less than negative 1 minus 6, negative 6. Okay. Then what you should have done is divided by this negative 4. What happens to an inequality when I divide by a negative number? The sign flips, right? So this becomes a greater than sign. And then negative 6 divided by negative 4. Leave it as an improper fraction, okay? So I know the 2 negatives are going to cancel out and make this a positive number. 6 over 4 can simplify down to 3 over 2. If you put 1.5, that's good too. Okay? now I have it isolated, right? Make sure you pay attention to when you're dividing by negative numbers or multiplying by negative numbers on these, okay? Because that does change your sign. Don't forget that. Okay, we're isolated. We can go ahead and solve this. Y minus 5 is greater than 3/2. I might go ahead and just change this to 1.5. I might make it easier on this one. Okay, drop the bars on this side, flip that sign, make it a negative 1.5. Okay, we're ready to solve. Good to go on this one. Oh, one more thing we forgot to look at. Was this a greater or a less than? It was a greater, right? So I'm going to real quick write or up here again, just so I know what I'm looking for here, what I want it to look like. So we'll go ahead and solve. We're going to add 5 on both sides. Y is greater than 6.5. Okay. Add 5 on this side. Y is less than negative 1.5 plus 5. If you can't do that in a calculator, make sure you just plug it in. You should get 3.5. Okay? Now what we're going to do, same as before, put these on a number line. Which one comes first? 3.5. What do my dots look like? They should be open. Y is greater than 6.5. Y is less than 3.5. And this was an OR. And that's what an OR should look like, right? Got a good gap going. Got 2 lines headed in opposite directions. I feel pretty good about that one. Okay? So get that one written down. Make sure you use these examples when you get to your homework today. But we're not quite there yet. We've got a couple more that we're going to go back and do real quick. And they are some special case ones. So we'll talk about how to do those now. Okay. Going back to example 2. Let's look at this one. How we isolate this one. Need to get this on the left by itself. So I've got to get rid of that negative 3. And to do that, I'm just going to divide by a negative 3. When I do that, I end up with just the absolute value of 2x minus 1 is, what happens when I divide it by a negative? Flips the sign, right? And then 21 divided by negative 3 is negative 7. So now that I'm isolated, I can decide, is this an and or an or? If it's a greater than sign, because again it's eating the variable, greater, it's going to be an or. Okay, let's go ahead and just try to solve this one like normal. I'm going to go ahead and tell you it's a special case, and we will realize how I could have spotted that early. But we'll solve it like normal first. So we'll split into 2 problems. 2x minus 1 is greater than or equal to negative 7. Keep it all the same. Okay. Drop the bars on the next one. Flip the sign and make that a negative 7. 2 negatives make a positive 7. Okay. Solve it like normal. Let's do it. Add 1 on both sides. 2x is greater than or equal to negative 6. Divide by 2. X is greater than or equal to negative 3. Same thing over here. 2x is less than or equal to 8. Divide by 2. X is less than or equal to 4. Okay? Put these on a number line and see what happens. So we know it's an or. We know what we want it to look like. We want it to have that gap. And let's see if it does. So close dots. We will see that if x is greater than or equal to negative 3, I would be shading this way. And if x was less than or equal to 4, I'd be shading this way. And since they're or problems, whoa, that's not what I wanted it to look like, right? I wanted it to have a gap in between. It does not. So immediately I think, oh my gosh, I did something wrong, okay? And I could go back and I could rework this problem, and I'm going to realize I didn't do anything wrong, okay? This one was a special case problem. If I go back up to where I isolated, okay? Anytime that you isolate and then you have a negative on that opposite side, okay, so 2x minus 1 is greater than or equal to negative 7, is the absolute value of anything always going to be greater than a negative 7? Think about that. Is the absolute value of anything always going to be bigger than a negative 7? Yeah, right? Because the absolute value of anything is always going to be positive. And a positive number is always going to be greater than or equal to negative 7. Okay? And when I graphed this, I got a line that covered my whole number line. If we think back to our other cases or our other problems that we did these on, what did that mean when I had everything defined? Was that all real numbers case? Okay? So when you get an OR problem, okay, that looks like this, and your graph is a line that is defining everything from negative infinity to infinity, it is going to be in all real numbers. Okay, and a way I could have spotted it is just to know from the get-go, if I have a negative number on the right side, not a negative variable, but a negative number, okay, I know it's going to be a special case. I then just need to look at the sign. Okay, so if the absolute value is greater than that negative number, that's true, so that's going to be all real numbers. But let's say that I isolated here and I had 2x minus 1 is less than or equal to negative 7 in that absolute value. Would that ever be true? Could a positive number ever be less than negative 7? No, it wouldn't. So that would be that no solution case, okay? So now that we know what those two things look like, let's go ahead and jump to number 3. So number 3, am I isolated yet? No, I'm not. What do I need to get rid of? I have an imaginary negative 1 out here, right? I have that negative sign. So I need to divide by negative 1. And when I do that, I end up with x plus 9, absolute value. Flip that sign, 9 divided by negative 1. Negative 9. I'm isolated, and I'm got a negative number over here. So I just need to think about, can the absolute value of something be less than a negative 9? Is that true or false? Can a positive number be less than negative 9? No. So I can go ahead and tell myself right here, spotted it, I know this is a no solution. I don't even have to show any more work. Okay, but if I didn't spot it, okay, we'll go ahead and we'll solve it like normal so we can see what a no solution looks like when you get down to it. So if I didn't spot it, I would have x plus 9 is less than negative 9, and x plus 9 is greater than negative 9, which would be 9. I would solve these like normal. I would end up with x is less than negative 18. X is greater than 9 minus 9, which is 0. Okay? And then I'd put these two things on a number line. Negative 18 and 0. I'd have open dots. X is greater than 0, less than negative 18. This looks like an OR problem, but if I go up here to where I isolated, this was a less than. Can an AND problem look like that? No, absolutely not. It can't. Why? Because an AND problem is what they have in common. These two things have nothing in common. They have two lines going in opposite directions. They have nothing that tells me where they met in the middle. Okay? So therefore, if you have a problem like this, it looks like an OR, but it's supposed to be an AND, it's going to be a no solution. Okay? And again, I could have spotted it up here because I would know that a positive number can never be less than a negative number. Okay? Let's try another one. Example 5. Another special case here. Try to spot this one early, okay? So I'm going to let this one play. Give you about 30 seconds to get this isolated and then make a decision, okay? is this one going to be, is it going to be a regular problem, or is it going to be a no solution or an all real numbers? So isolate it and let me know. So if you're having trouble here, just pretend that this was a variable. And how would I get that x by itself? What would I do? Give about 10 more seconds to get this one isolated and make a decision. Okay, let's try it. So, to get this by itself, got to get rid of this 4. Absolute value of 2x plus 5 is going to be less than negative 6 plus 4. Negative 2. Can the absolute value of anything be less than negative 2? Can a positive number be less than negative 2? Hopefully you decided it was a no solution. A positive number cannot be less than negative 2. Okay? But if I didn't see it, let's just go ahead and work this one out. Less than means I want this to look like an and problem. My two problems that I'm going to split into, I'm going to have 2x plus 5 is less than negative 2, and 2x plus 5 is greater than a negative 2. Subtract the 5. 2x is less than negative 7. X is less than negative 3.5. Subtract 5. 2x is greater than negative 3. X is greater than negative 1.5. Put them on a number line. Which one is less? So which one's coming first? Negative 3.5, because again, that's further away from 0, right? 0 would be over here. What kind of dots would I have here? Open, open. X is greater than negative 1.5, less than negative 3.5. And I know that this was supposed to be an and problem, but it's not, right? It's a totally an or problem, which means no solution. Okay, and again, could have spotted it here, but if I didn't, that's okay. Okay, you can work it out, but as long as you do your work right, you'll still see that my and problem can't look like that. Okay, all right, that's all I got for you guys. Let me know if you have questions. Okay, thank you very much. I'll talk to you guys later.